Okay, this is chapter 13, simple probability. And we already done in the first part, probability and also the sample space. So now we are going to see the events. Okay, so events is based on your sample space or from your sample space. Okay, after an experiment, you get a sample space already, isn't it? So based on the sample space, you get the list of the outcome or set of the outcome which is fulfill some condition. Okay, and then if I ask how many outcome from the sample space is fulfill the condition, so there is a number of sample space. Okay, that means I want you to state the number of sample space. So how many outcome based on the sample space fulfill the certain condition? That is number of sample space. So now we look at some example. Okay, so now the question is, the experiment is throw a fair coin. So when you throw a fair coin, the sample space is head and tails. So now the events A is getting tails. Okay, it's getting tails. So that means A is the set, and I write down tails. So this is a event. Okay, and then this is a number of events. Okay, and then events and sample space we can represent in Venn diagram. We can represent the sample space and also the events in Venn diagram, just like what I show you here. Okay, this is a Venn diagram. Okay, but this Venn diagram actually represents the sample space and also the event I have in this example. So tails is set A. Set A is referred to events A, getting tails. So set B is referred to getting head. Okay, this is the events B that is getting head. So this is the condition. You must fulfill the condition, then only you can write inside the set B. Okay, so we're going to see next example. Okay, this is next example. Next example is a letter chosen from a words mathematics. So the sample space will be all the letter for the words mathematics. So now I have sample space and I want to know how many the letter inside the words can fulfill the condition vowel letter. Okay, so now I want to find events A is getting the vowel letter. So this is the condition. Now my condition is vowel letter. So that means based on the sample space I have, the vowel letter will be A, E, and another A repeat, and also I. So that's why the event set will be A, E, A, I, like this, what I have give you inside here. Okay, with the set notation. Okay, so this is the event A, E, A, I. Okay, based on the sample space. Okay, we cannot take any letter out of the sample space. That's why in here I'm not writing down O or I'm not writing down U. Okay, O and U, both of them are vowel letter, but these two letters is not inside the words mathematics. So that means I cannot take as a event. So now I count, I have 1, 2, 3, 4. I have 4 different letters in the events A. So means number of events will be 4. The number of events will be 4. And also same, the events and sample space can be represented in Venn diagram. Can be represented in Venn diagram. So I draw out the Venn diagram to represent the sample space and also the events. Okay, as you see, A is a vowel, B is a consonant. Okay, so this is a Venn diagram. And then we're going to see the third example. The third example is a fruit picked from a box. Okay, and then inside the box containing with 5 apples and 10 orange. So the sample space will be all the orange and apples. Okay, so now the events A is getting apple. Okay, so means the sample space will be all the apple in the box. So I can write the sample space like apple number 1, apple 2, apple 3, apple 4, apple 5. Okay, must until 5 apple only. Means that is wrong if I write down apple number 6 and also apple number 7 inside the event set, because according to the questions I only have 5 apples. Okay, so that means we cannot write another apple 6 or apple 7, but only 5 apples. Okay, so that means the number of sample space will be 5, because I have 5 different apples. Okay, so I hope you understand about the events. Okay, that's all for this part.